Hello, I'm Art Eggers, and I'm going to be the facilitator, if you will, in your AC for electronics class. I just like to give you a quick interview of this class and the contents. Of course, you're expected to know and to have remembered the fundamentals of your ET131DC for electronics course, and if you've taken the ET111B math for electronics, that you have also have a good command of those. So a little bit about this course. Primarily, the course, although you have a different edition, which is pretty much a composite of this textbook. This is an old 6th edition, but Floyd edition, and it contained both AC and DC. I've been using this book to teach AC and DC here for almost 20 years, and most of the content that I've put together, most of the assessments, homeworks, exam questions, whatever, I use this textbook, and I use the material that I've put together for this textbook. Like I said, what you have and have purchased is a combination of the AC portion of this textbook and another textbook that was reactive devices or non-passive devices when we start getting into diodes, transistors, and operational amplifiers. So this textbook, like I said, is one that I have used for going on 20 years. If you take a look at this textbook, starting about halfway through the textbook, we have a chapter 11 called Introduction to Alternating Current and Voltage, and this information is, for the most part, what you see in your textbook. So I rely on this textbook and have for 20 years. When I go through and I do example problems where I have them all worked out so that I know what I'm talking about when we're talking about these types of these problems. It's from information that I've used in the past. So in this course, we're going to go over phasors and complex numbers. Phasors are really just vectors, really that relationship that is a right triangle relationship. If you haven't had phasors before, you need to make sure that you pay particular attention to this section. In your textbook, it goes through and gives you a pretty good breakdown of how we develop the phasor relationship and use that information from the right triangle to develop the vectors or the phasors. We start looking at the complex number system, and we get an understanding of how we use what we have learned as the XY axis or the rectangular or the Cartesian axis to understand the imaginary and the real axis as it applies to complex numbers. So this might be something that's new to you. It's not advanced math. I get a lot of students that say, "Oh yeah, you're just bringing up all this advanced math in this course." This is stuff from high school. Okay, this is not advanced math. This is Pythagorean theorem and the application of entry level, very fundamental right triangle. You can see on the bottom of the page here, right triangle depiction. So try not to get upset when you start seeing the phasor relationships. One thing I will tell you is that as you use this more and more, and you can see from the example there, we use something called the J operator in your high school math and your ET111. The J operator was introduced to you, and in algebra on the math side, we call the I operator or the imaginary operator. So a lot of the information is information from this textbook. It's legacy information, but none of this has changed over the years. Like I said, for 20 years, I've been relying on this textbook. I also integrate other textbooks and information when I want to expand on a topic that I think might be worthwhile to you. I've got a book here called Basic Engineering Circuit Analysis that I've used in the past. This happens to be the 8th edition, so it's pretty old. Irwin and Nelms. It's got some great information in it. The portions of the devices, circuits, and applications, Floyd and Buchla. This happens to be an 8th edition. A lot of the information, introductory information about diodes, transistors, and operational amplifiers actually comes out of this textbook or this textbook. They both contain the same information. In the past, when we had you buy the textbook, we had you buy this textbook specifically for solid-state devices. So this book by Floyd, Electronic Devices, which I actually helped in the authorship. If you look at the credits in this textbook, it actually identifies me as one of the reviewers and co-authorship on this. So I have a bit of a background in this textbook. I've also used some others that are just kind of hit and miss. This one, Foundation of Electronics, Circuits and Devices. In this case, conventional flow versus electron flow, things that you will run into in your study. Again, I like to draw from other sources when I put things together, whether it's in the lectures, in example problems, or in assessments, so that you get a broad introduction to the subject. In the past, I've gotten a lot of folks that have some background in electronics. Maybe they were military folks. I myself spent 20 years in the Air Force. I was an electronics technician. I taught electronics technician in the field training courses that I taught for air-launched missile systems, guidance systems. So, I do have a pretty extensive background that preceded my studies in electrical engineering. And I can tell you, in electrical engineering, the approach for engineering electric circuits is way different than what you get in this book. So if you want to look at one here, Dorf and Svoboda, on how they attack circuits and circuit analysis using some of the models in here. This happens to be an operational amplifier, but if you go to some of the basics here, they use some modeling in this textbook that I guarantee you will never see before, and it's actually introduced to you in the early stages as a calculus-based problem. So if you want to look at advanced math in the electronics of studies, get this copy of Dorf and Svoboda and use it for your studies. I guarantee you it will totally eclipse what you're learning in your textbook that you have here. So all I can say is, if you haven't looked at your math in a while, go to the links that I've provided for ET111, Math for Electronics, and get back up to speed on your basic algebra and basic right triangle and complex numbers that were introduced to you in ET111. If you took a math course, it probably wasn't introduced to you or presented to you in the same way that our math course is for electronics. In most cases, mathematicians and whatnot have no idea what we're talking about in terms of electronics. Again, go back and review things in your ET111, your ET131 course. Specifically, take a look at things like Thevenin's theorem, the Norton's theorem, superposition theorem. Go back and look at those handlings in a DC environment before you try to understand them in an AC environment, because we are going to hit them again and they'll be used. We're going to use them in things like maximum power transfer. So I welcome you to the course. You've got a lot of work ahead of you. If you have questions, always reach out to me. Don't feel intimidated to reach out. Okay, we'll see you in class.